Hi, my name is Kirill Gavriluk. I work on Azure App Service, one integrated app platform on Azure for your mobile, web, API, or integration apps. Today, we're going to talk about mobile features of App Service that help you build your enterprise mobile apps. Through several industry examples, I'm going to show you how these features work in conjunction with other goodness of App Service or other great things that Azure offers you today. App Service mobile features, we call them App Service mobile apps, is a set of functionality available for your enterprise apps, consumer or line of business. Whether you target iOS, Windows, or Android, whether you build native apps using Objective-C or Java, or use cross-platform frameworks like Xamarin, Cordova, Titanium, Sencha, or maybe you're just building mobile web sites, App Service mobile features help you and make your life easier. App Service allows you to connect to data, variety of data sources. Whether your data is stored in SQL in Azure or SQL on premises, whether it's in Mongo, in table storage, whether you need to work with Office 365 APIs, Salesforce, Dynamics, or other enterprise APIs, App Service offers you easy mobile connectivity to data, secure, and also allows you to build apps that work with data in offline mode without any internet connectivity, and later on sync the changes that users made to the backend, to your data stores, like Salesforce, Dynamics, or SQL, on premises or in the cloud. App Service allows you to authenticate your users. For consumer apps, this is typically custom logins or social identity providers, like Facebook or Google. For enterprise line of business apps, typically it's corporate credentials, Active Directory. We use Azure Active Directory that can be set up to synchronize to your on-premise Active Directory. Your apps need to be engaging. And App Service offers you a fairly comprehensive set of functionality based on native platform push notifications for iOS, Android, OS X, as well as in-browser push notifications for Chrome and Safari, or in-app push notifications for your apps that offer much lower latency. You can extend these capabilities with your code in .NET, Node, Java, PHP, you name it. App Service is a great home for your apps, no matter which language they're written in. Let me show you a real-life example of an App Service customer, in this case, Transport for London, how they build enterprise mobile solutions using these features. Transport for London employs thousands of employees. Transport for London manages a number of transportation means in London, including London Tube. Transport for London wanted to offer employees ability to report assets needing repairs as they walk through the underground stations. They built an app, it's an iOS app called Fault Reporting, that allows employees to authenticate using their corporate credentials, allows employees to take pictures of assets that need repair, benches, signs, and adds the comments and submits those reports, allows them to do that in offline mode when connectivity is not available, since it's pretty often the case in the underground. And then later, when connectivity is present, the app will sync the changes, will sync the updates to the on-premises background system. The app allows employees to receive alerts, notifying them about the changes in status of these assets reports. Let's take a look how App Service allows customers to build such apps. This is what Transport for London used. Transport for London built a native iOS app called Fault Reporting. This app connects to an App Service, specifically App Service Mobile Backend. In its turn, App Service Mobile Backend connects to a SQL database where it stores everything that the app submits. But it also queues up using service bus queues changes that will later on be propagated using a web job, another App Service feature. In a simple fragment of code, we're able to Transport for London is able to propagate these changes to an ERP, local ERP system. Transport for London is very cautious about their data. So all of the data, like many enterprises, is stored on premises. And to do that, they set up a VPN, a virtual network, private network, with AppService, you can do this using AppService environments. Another great feature of AppService that offers you an independent, isolated scale unit for your apps that you can put in your own virtual private network that you can have dedicated IPs for, and you can securely connect to on-premise resources like ERP systems, like on-premise Office installations or CRM systems, or SQL databases, which in this case is also around on-premise. Finally, the app alerts users when the changes are made to their requests, and it's done using notification hubs, cross-platform push notifications engine that is also offered to you as part of AppService. Users authenticate using corporate credentials, using Azure Active Directory that is set up to synchronize with on-premise directory. As such, I'm just logging in with my corporate password and user. This app supports offline mode. So users can enter data in offline and then later on synchronize with SQL and ERP backends using AppService. How does this work? And why do you use data sync? AppService data sync features that enables this offline mode and synchronization is useful not only for these operations where you store and forward, but it also allows your app to work reliably again, in the presence of intermittent network connectivity. It allows end users to create and modify data when the network is not available. It allows you to seamlessly synchronize data across multiple devices or improve app responsiveness by caching server data locally on the device. This is how offline data sync works in AppService. We use SQLite on the client for most of the platforms. In iOS native, we use Core Data, which in its turn also use SQLite. All the data operations are performed against SQLite tables. Once it's time to sync the changes, when connectivity is available, the AppService replays all the changes from the client against cloud and endpoints hosted in AppService mobile backend. We call those endpoints tables. Those are just OData, mobile-friendly OData endpoints that know something about offline sync. And those endpoints can be projected to SQL or on-premises SQL, in case of Transport for London. And you can map arbitrary complex data models that typically you have in your enterprise systems to mobile-friendly views, data views, using these tables. In case of .NET, we use Automapper, but you can use any mapping technology you like or map it yourself. Now, data is not always stored in SQL. And in fact, AppService allows you to connect your data on the client and synchronize with a variety of data stores, whether it's Dynamics CRM, Salesforce, Office 365 APIs, you name it. Actually, I have another example of a customer. In this case, it's a large mining company. And our partner, Ignia, was asked to build hazard reporting app, a scenario to report incidents on mining sites, very similar scenario to the Transport for London. But in this case, the incidents are managed in Dynamics CRM. And what Ignia did is it synchronized the local data with Dynamics CRM directly using AppService Data Sync. Offline data sync is not only used for these replay CRUD operations. It is also pretty handy if you just want to synchronize large amounts of reference data on the client so that you always have the freshest data on the go, whether the network is there or not. In case of the same large mining company, they wanted to offer a mobile version of their railway rulebook, something that is pretty important for security and needs to be always available and always working. These rules are constantly being updated, and AppService Data Sync allows rules to be managed on the backend, in this case in Dynamics CRM system, and synchronized to the client whenever network is available, and keep so that they can be kept fresh, and always available whenever someone wants to look them up on their device. I talked a lot about different use cases that are built by our customers. Let me show you code fragments and how little code these customers needed to write in order to build these systems using AppService. Let me show you a field engineer, a mobile dashboard. I have it right here on my iPad. This is a mobile dashboard for engineer that has to work in the field for a prototypical cable company. This pattern is fairly common across variety of industries, whether it's cable, whether it's mining, whether it's transportation, you name it. This app allows engineers to manage their jobs, use their jobs, and update them. Let me show you in more detail. Here I have it in an iOS emulator running. Our field engineer, in our case, is going to be Carla Davis. She can view jobs assigned to her. In this case, she is repairing cables across different residences. And she's currently working on cables problems at Omar's house. She can view her schedule. She can update the status of her jobs as she goes along and switch between jobs, as well as receive notifications when her schedule changes. Let me walk you through how this app is built. And note that this app needs to authenticate Carla Davis using her corporate credentials, needs to support offline mode because in some residences, connectivity will not be there. It needs to allow for push notifications to work. It needs to be able to synchronize changes to the data to the backend. This app stores the individual job details and tracks them in a CRM system. In our case, it's Salesforce. And it also stores the scheduling information in SQL. All of this done using App Service. On the client, let me switch it back. Here I have Xamarin IDE, since I'm running on a Mac. This app is built using Xamarin Forms, a great way to build portable apps, write them once, including the UI, and compile them for iOS and Android operating systems. In this case, I have all my UI views built in C#, and the platform-specific stuff is only limited to resources, images, and so on. The work that I perform in this app with the service, with the backend, is all encapsulated in this job service controller. We provide you SDK for every platform, whether it's native or cross-platform frameworks. In this case, we provide you a portable client library that works on Xamarin as well as works in Windows for Windows apps. This SDK, for those of you familiar with mobile services, hasn't really changed. So you can, it largely works the same way. You provide the URL of the mobile backend, which we'll show later on. In this case, it's field engineer 02 mobile/code. Because we're going to support offline scenarios, and we need to be able to enable this app to synchronize data to the backend, we're going to use data sync feature of App Service. And we need to initialize this feature with the local SQLite database. So here I have SQLite database name. All the CRUD operations are offered in the SDK in the form of table proxies. Remember, we call the remote endpoints tables, so local data stores are also called tables. And these table APIs allow you to use standard link syntax to perform queries, updates, and other data operations. All of these data operations, in our case, are going to be performed against a local SQLite store, which I initialized so I initialized my sync context right here in this line with my SQLite store. I optionally could have added a SQL sync handler, that allows me to handle override conflict handling by myself. So here's how a query looks. It's just one line of code using link syntax. Updates are even simpler. And once it's time to synchronize the changes, App Service allows you to replace the changes you performed locally against remote table endpoints, which are just data endpoints. First, we're going to ensure that Carla Davis is logged in. And if she isn't, we're going to use Azure Active Directory authentication. And this is the lines that you need to write. There's one line of code that allows you to authenticate in your app, authenticate users against Azure Active Directory. Azure Active Directory can be synchronized with on-premise Active Directory, so you can really authenticate your employees with corporate credentials. Once employees authenticated, we push the changes against all the changes from locally to remote endpoints. And then we pull a subset of all the changes for a subset of entities, so a subset of tables, and subset of rows that are interested to this user. And in my case, for the demo's sake, I hard-coded the user ID, but we could use the Active Directory user ID here to scope the exact rows that we are syncing down to the client. And then we pull async actually synchronizes. Both push and pull can trigger conflicts. In fact, push is likely to trigger conflicts. And conflicts can be handled via sync handler that I showed you where to plug in earlier, or can be handled right here by catching the exception and performing ad hoc conflict handling. Now let me go back to my application, which is running. So this app supports offline sync and is currently in simulated offline mode. I'm simulating with this toggle, simulating lack of connectivity. So I can perform some changes. I can pretend that Carla Davis performed the job, and so she is ready to sign off. She says that she replaced cable box and marked the job completed. Now let me go to Salesforce, which is the real source of truth, where all these changes are going to be synchronized. And here I have my jobs. And as you can see, Omar's job is still marked working because our app is still in offline mode. Our device doesn't have network connectivity. So I'm going to make one more change. I'm going to edit the Josh's job and change its title from closed back to working, because we got a complaint from Josh that cable wasn't really repaired and more work needs to be done. So we want to direct Carla to go and fix it. Now let's go back to cases. So now I have here, in Salesforce, I have Josh marked status working and Omar marked status working. But on the client, I have Omar status completed, and Josh is also status completed. Let me switch the toggle to online. The app prompts me to authenticate, right? Because before we perform any changes, Carla better authenticate and proves that she is who she is. We're going to use Azure Active Directory, and we're going to supply the password. All right. And what you will see happening is Josh now is the status of the Josh job is working in progress because Carla needs to go and perform some work. While Omar, if we go back to Salesforce, the status of Omar job should have changed to closed. And exactly right, the status of Omar is changed to close. So you can see how App Service helped build an app that allows employees to work with their data in offline mode, and then later on synchronize the changes to a CRM system. In our case, Salesforce, or as in the case of that large mining companies that Ignia helped build an app, Dynamic CRM. We support both. Now let's go to the backend and see how App Service actually helps you with this, in addition to the SDK. What's happening on the backend? So first, App Service enjoys a nice management experience in the Azure Preview portal, right? And here we have a management blade for my mobile backend. If you're familiar with Azure Web Apps, which is another feature of App Service, you'll recognize that it's the same management blade. What we did is we added mobile features and made them available to any app running on App Service. Right here in settings, you'll see mobile features, and you can add data, push, mobile authentication. We even help you with a nice interactive quick start to get started. And you can choose the platform. In our case, it was Xamarin Forms. And you can follow the steps and quickly get a working app running and download and run it, connected to the backend. Other features we used in this app was authentication. We just authenticated using Azure Active Directory. And right here, you can manage your Active Directory settings. And this app, just to prove that I'm not showing you any dummies, you can see that our app is configured with an Active Directory in App Service. Typically, in these apps, you extend App Service capabilities with custom code. And in our case, we did just that. So let me go to Visual Studio, running on my Windows virtual machine in this case. And here I have my Visual Studio, and this is my backend for my mobile app, Field Engineer. It's a standard MVC template. All I did was I added one data object called jobs that encapsulates our jobs data structure. Added DB context because all the changes that apps is working with, all the data is first synchronized to SQL, that runs in SQL Azure in this case. And I have added job controller, which is a stable controller I mentioned earlier. It helps you connect and expose your data sources, whatever they are, via mobile-friendly or data endpoints that offers you a number of functionality built in, like offline sync that we use in this case. And this stable controller fronts both SQL as well as Salesforce so that you can synchronize the changes to SQL as well as perform the changes against Salesforce, which is the source of truth for our jobs. So here I showed you how, with very few lines of code, we can build an app cross-platform that works on iOS and Android, that allows employees to authenticate using their corporate credentials, perform data changes, in this case, update status of their jobs and view their job schedule, and synchronize that data with SQL and Salesforce CRM or Dynamics, as we mentioned earlier. Alert employees via push notifications, all of this using App Service. This solution is available on GitHub. You can see the client right here in Xamarin Forms, available for iOS and Android. You'll see the backend solutions that I just showed you in Visual Studio right here. I also added in GitHub this web job that synchronizes between the Salesforce and SQL to ensure that those stay in sync, very similar to the pattern used by Transport for London in the solution we discussed earlier. I just demoed for you a field engineer, an app that offers a mobile dashboard to an engineer of prototypical cable company, an app allowing the user to authenticate using corporate credentials, perform changes and update their jobs in offline mode when connectivity is not available, and later on synchronize those changes against the enterprise backend systems, in this case, SQL database running in Azure, and Salesforce CRM system. You can also connect this app to a dynamic CRM system. App Service supports both options. This app is built using Xamarin Forms on the client. Xamarin Forms allows you to build cross-platform apps in C#, both business logic and UI, so you don't have to write platform-specific code. I'd like to thank you for spending this time with me and encourage you to go and check out App Service in the App Service and Azure Mobile Dev Centers right here, and then take a look at Field Engineer app available to you on GitHub and see how App Service features are built in real use cases, very similar to what Transport for London and the mining company had done. Thank you.